Hey everybody, today we're working with acid-base reactions. Acids and bases are examples of electrolytes, chemicals that conduct electricity when they're dissolved in water because they contain ions. So there's two kinds of electrolytes, strong and weak. The strong are the ones that conduct electricity strongly. The weaks conduct just a little bit, so acids and bases. The strong acids and bases are strong electrolytes, so you need to memorize the strong acids. They separate completely into ions. And the weaks, they are everything that you don't memorize as far as acids and bases go. So they separate partially into ions, so they conduct a little bit. Partially means just a few percent usually, whereas strong means basically 100%. For the acids, the list to memorize is sulfuric, H2SO4, nitric, HNO3, perchloric, HClO4, chloric, HClO3, hydrochloric, HCl, hydrobromic, HBr, hydroiodic, HI. The bases, you don't really need a list, you just need to know that it's the hydroxides that are soluble. So that's ammonium hydroxide, the group 1 hydroxides, that would be lithium hydroxide, sodium hydroxide, potassium hydroxide are the common ones. And the group 2 hydroxides like magnesium hydroxide, calcium hydroxides, that would be MgOH2, CaOH2. Those ones in group 2 are slightly soluble, but the part that dissolve separate all the way into ions, so they're still considered strong bases. Other chemicals that aren't acids and bases can be strong electrolytes, like salt NaCl is a strong electrolyte. So that's just depends on whether it's soluble or not. If it's ionic and it's soluble, then it's a strong electrolyte. There aren't really any that are weak electrolytes because they dissolve or they don't. And so to figure out if they dissolve, we use the solubility rules. So main thing that's important, you really have to memorize this list and you have to memorize it well. And these ones too. Okay, once you know the strong electrolytes, you can determine the relative conductivity of solutions. It's easy. If there's more ions, then moving charges conduct electricity. So they're better conductors. Electrons don't swim, you need an ion to carry the charge. So the strong electrolytes, those are good conductors, or strong acids or strong bases, but there's still differences. For example, which would conduct more, a 1 molar solution of sodium chloride or a 1 molar solution of ammonium sulfate? Well, you just need to figure out which one has more ions. So group 1 is always soluble, so this is soluble, separates completely into ions, and ammonium is always soluble, solubility rule 1, so this separates completely into ions, so you just need to count. The NaCl will make 1 molar of Na plus and 1 molar of Cl minus, that's 2 molar concentration of ions. The ammonium sulfate will make 2 molar concentration of ammonium and 1 molar concentration of sulfate, so that's a total of 3 molar ions. So this one has more ions, so it conducts better. That's all there is to that. You've got to count the ions. Okay, so for reactions in solution, like the acids and bases we were talking about, we're going to work with neutralization reactions today. That means an acid reacting with a base to make water. That's why it's called neutralization, because water is defined to be neutral, plus a salt, a ionic compound. So for example, if you react sodium hydroxide and hydrochloric acid, to write the products, what you have to know is that all of the hydroxides and all of the H's react to make the water, because it's a neutralization reaction. And then you use the leftovers to form the ionic compound, the salt. But you do have to find the subscript. So here, Na is 1 plus and Cl is 1 minus, so it stays as it is. NaCl is NaCl. If one of these was plus 2, then you'd have a 2 subscript here. And then you make sure the equation is balanced. This one is. Here's a harder one, sodium hydroxide and sulfuric acid. Predict the products. So again, all of the hydroxides and all of the H's The H's make this thing an acid, the H's come off. They make water. So even though this isn't balanced, we'll take care of that with the coefficients when we balance it. So you don't try to make H2O2 or something, it makes water. When acids react with bases, they make water. So then the leftovers make the ionic solid, the salt. We have Na and SO4, but you can't just write them, you have to check and see if that's the correct formula. The way you write ionic formulas is write the ions with their charges, cross the charges to the subscripts, reduce. So this is Na2SO4. Then when we balance it, it's easiest to just think about the waters. If we have 2 hydrogens, we need it to react with 2 hydroxides and make 2 waters. So that's a fast way to balance these. This is called a molecular equation when you write everything as molecules, everything together, even if it's a solution that's separated into ions. If you write it together, it's called molecular equation. Last for today, we'll learn about ionic equations and net ionic equations. So I'm going to write the same equation again. You probably don't have to in your notes, but for ionic equations, I'm writing this again, except I'm going to add in the symbols of state there. So aqueous for the ones that separate into ions, liquid for water. So this is soluble, so it's a strong electrolyte. This is strong acid, so it's a strong electrolyte. This is strong base, so it's a strong electrolyte. So those are separated completely into ions. How you indicate that is by saying AQ, which means they're dissolved. Okay, so for ionic equations, if it is separated into ions, you write it as ions. So that one becomes 2 sodium ions and 2 hydroxide ions because it's sodium hydroxide. Acids become the H plus and the rest of it. So 2 H pluses and SO4 minus 2. Water does not separate into ions, so it stays. Sodium sulfate is soluble, so it separates into ions completely. So it'll be 2 sodiums and a sulfate. Sodium sulfate makes sodium and sulfate ions. Okay, that's called the ionic equation. It's called the complete ionic equation. If we show only the things that are changing and cross out the rest, that becomes the net ionic equation. So if we cross out sodium, spectator ion because it's not changing at all, and if we cross out sulfate, another spectator ion because it's not changing at all, that becomes the net ionic equation. So here's my net ionic equation. 2 hydroxides and 2 H pluses form 2 waters.